Okay, hi guys. So the little remote that came with my tripod to hold my phone isn't working, so you'll see me jumping in and out. But here we are, video number 2. And this is still section 8.4. Hopefully you got through the assignment on simplifying rational functions. Now, on this video, we're going to learn how to multiply and divide rational expressions. So again, let's start with some 5th grade math here. Can you remember back that far? Maybe your little brother or sister's home and they can help you with this, okay? All right, if we were gonna multiply 25 over 40 times 16 over 75, please tell me you would not just multiply 25 times 16, get some, big number, what would that be, 400, then you'd have to multiply 40 times 75 and get some big number, and then try to simplify that. That's not the most efficient way to do this. Okay, what we want to do is to do some simplifying before we multiply. So we have smaller numbers to work with. So I know that 75 is 25 times 3. So rather than waiting, if I don't simplify now, I'm still going to have that 25 as a factor in my numerator. I'm still going to have a 25 times 3 in the denominator. So I'm going to pair up these right now and make those both become 1. That way I get rid of those larger numbers. I know that a common 16 is 8 times 2, and 40 is 8 times 5. And now I can take those 8s, pair up them into 1. I don't think there's anything else I can do, so I'm going to multiply now. That's 1 times 2 is 2. In the denominator, 5 times 3 is 15, and there's my final answer, 2 over 15. And if I'm making any mistakes on here, you're not here to catch me, so somebody email and say, Mrs. A, in video 2, you messed up on this problem or something. Okay, so let's look at the next one. This is still Algebra 1. You should be able to handle this. Again, rather than multiply first, I'm going to search for factors from the numerator that are the same as the factors in the denominator. You can use any factor from any numerator with any factor from any denominator. So, this was a typo. All right, guys, I'm going to change this. This was supposed to be, this is A, type the wrong number, a 14, okay? So that's not going to mess you up. It'll make it just a little sweeter for us. So I can recognize that this is 10 times 5, and I can take that 10 and that 10 and create a 1. I can take this y, now watch, I can either pair it with this one or this one. It doesn't matter. It doesn't have to be on a diagonal, okay? And then I wanted this to be 14 because that's 7 times 2. This is 7 times 6. The 7s can pair up and become a 1. And what else do I have? This x to the second and this x to the third, 2 of these x's can pair with 2 of these x's, leaving an x there. Are you following me? I hope I'm not losing you. Now, I can now pair this x with this x and make those 1. And I think now that's all I can do. So what do I have left in the numerator? A 6, a 5, and a y. So that's 30y over, 2. So obviously I missed something. I missed that I could have done 6 and 2, but I'll just take care of that now and make that 15y. The 2, make this 15 times 2 and get rid of the 2 there. Okay, so that's pretty much Alg 1. So now let's move along and go to the big boy stuff. So now we want to use the same strategy, but I'm going to put some polynomials in our rational functions now. So again, what was our mantra when we were working with these? Factor first, factor first. So I'm going to factor above these just for the sake of room. So if I factor, how am I going to factor 3x minus 3x squared? if you said GCF, you're right. I'm going to take a GCF of 3x out, and that's going to leave 1 minus x. Okay? I'm going to factor the denominator. This is going to be the tough part. The work is the factoring. The simplification's easy. So x and x, 5 and 1. I want a positive 4, so that's going to be positive and negative. Okay? Let's move over here. I'm going to factor up here, x and x. Since my middle term is 1, 20's got some factor pairs, 20 and 1, 10 and 2, 5 and 4. Obviously, I'm going to want to use 5 and 4 to get that 1. I'm going to want a positive 5 and a negative 4. Those will multiply to give me negative 20, but the positive 5x and negative 4x will add up to give me positive 1. And then 3x, that's already factored. Can't do anything with 3x. So now, what am I going to do? What can I start simplifying before I multiply? This 3, those are paired. These, those are paired. Ha-ha! I got an x plus 5 and an x plus 5. Those are paired. Okay? So that's good. Now, I got a 1 minus x and an x minus 1. Are those the same? I'm hoping you said no, because they're not. Subtraction's not commutative. But hopefully you know that they are opposites. If x was 6, this would be negative 5 and this would be positive 5. If x was 10, that would be negative 9. This is positive 9. Now, you wouldn't tell me that you can't simplify that because the denominator's negative 9. You would say that simplifies to negative 1. Well, I can do the same thing here. X minus 1 and 1 minus x are opposites. So I can't simplify them to 1, but it does simplify to a negative 1 somewhere in the numerator and denominator. I usually put it in the numerator. Okay, so I think that's all I can do. So now if I go to multiply, all I have there is negative 1 times x minus 4 all over, everything from our denominator simplified. So it's just 1, and we never leave, if it says simplified, don't leave something over 1. That's not really simplified. So this is just going to be this if I distribute the 1 out. Okay? All right, so let's do this next one. I'm going to get rid of this so I have some room. All right, so first thing we have to do, I'm going to move this down a little bit so I got some room, is to factor. Now, x plus 5 is prime. I can't factor that, so I put parentheses around it to remind me that I have to factor that whole quantity. I can't take just parts of it. X squared minus 1 is going to become x minus 1x plus 1. That's the difference of two squares. Now, if you have a polynomial here, just remember that's like all over 1. So I'm going to go ahead and factor this into x minus 1 times x minus 1. Now, do you see anything that I can simplify? I think I can take one of these x minus 1s with one of these and pair those up, but I think that's about all I can do. So my final answer is going to be x plus 5 times x plus 1 all over x minus 1. Okay? Now, x plus 1 and x minus 1 are not opposite, so I can't do anything with those. Okay? And I'm not going to ask you to multiply to FOIL those out. Just leave it in factored form. It'll make your life a little bit easier. We don't need any more stress right now. All right, and now, only for the brave. Now, you can handle these. But notice, these are now what? Division problems, okay? So I'm still going, this is where you got to be careful and just not try, you can't be doing 3 things at once when you do these. So I'm going to go through and factor. So I'm going to factor 2x minus 10 by taking out a GCF. All right, this numerator, how am I going to factor that? It's not a trinomial. It's not the difference of two squares. This is a square, but that's not. So I got to use GCF. Now you know that, and I should write this all out, but I don't want to belabor the point here. When you divide, it's the same as multiplying by the reciprocal, correct? So I'm going to multiply, but that means this is going to come down here. So this is moving down here, and I'm factoring it by taking a GCF out. This is moving up here, and how do I factor that? X and X, what factors of 30 can give me 11? 6 and 5. Now notice, why are they both negative? Because I need to get a positive 30 when I multiply and a negative 11 when I add them. All right, so now what do you see that we can simplify before we multiply? I think I can do this and this, so that's good. Those can become 1. Oh, good. X minus 5 and X minus 5. That's good. Now, if I multiply right now, I would have 7x over 2 times x, or 2x. Because this is multiplication, I am allowed to simplify those x's, and my answer is 7 over 2. Okay? And last one. This one's just going to be a little bit more challenging factoring. So I'm going to go ahead and factor this numerator. This is going to be a little tougher here. So this one's tough because with 6x squared, I could use 3x and 2x or 6x and 1x. Now, if you remember, these are going to be opposite signs. And I told you if the middle term is negative, there's a better chance that you're going to use factors that are closer together, like 3 and 2, not 6 and 1. 5 and 3, not 15 and 1. So I'm going to guess, and I have no idea, honestly, I haven't done this problem yet, that it's going to be 3 and 2. Now I got to look at factors of 15, and I have to put them in such a way that I can get a 1. So again, I'm going to try 5 and 3. 15 and 1, if I use 15, it's going to give me a big product, and I only want a 1. So I think if I put a 5 here and a 3 here, that's going to do it for me. Because this will give me 10x, these will give me, the outers will give me 9x, and I can get a 1 from that. So I'm going to want a positive there and a negative there. You see how that'll work? This will give me my 6x squared. These will multiply and give me that. Negative 9x and positive 10x will give me my positive 1x. Okay, now, originally, this is like this. But when I go to multiply, it's going to become 1 over 3x squared plus 5x. So this is inverting. Now, can I factor this? I hope you said yes by taking out a GCF of x, which is going to leave 3x plus 5. Now it's a multiplication problem. What can I cancel? Oh boy, that's this now. This and this become 1. I think that's it. Okay, so what do I have left in my numerator now? A 2x minus 3 times a 1, 2x minus 3, and what do I have in my denominator? A 4x squared times an x, which is 4x cubed. And again, resist the urge to try to do anything with the 2 and the 4, the x and 3. We cannot do that because of this minus sign there. And there we have it. So again, look on PowerSchool for the assignments. I hope you understand I'm trying my best. This is a lot of work, trying to learn how to do all these things with technology and keep track of everything, but we'll get into a rhythm. So good luck, guys. See you next time.